The reason for Mach's expensive border crossing is its focus on portability. What that means is that the Mach microkernel is architecture independent to allow that Mach microkernel to run on several different processor architectures. What that means is that there's going to be a code bloat in the Mach microkernel because it has to have the personality for any architecture that it may need to run on. In particular, in the Mach microkernel, there is an architecture-independent part of the microkernel, an architecture-specific part of the microkernel. The two together results in a significant code bloat, which means it has a large memory footprint, which means it has lesser locality, which means you're going to have more cache misses and pollution of the cache. And that is the reason why you have a longer latency for border crossing in Mach as opposed to the theoretically smallest number of processor cycles in order to go from user space to kernel space. As I mentioned earlier, LeadK did back-of-the-envelope calculation on the same processor hardware and said that it should take about 107 cycles to go from user space to kernel space. And then he implemented L3 microkernel and showed that it took only 123 processor cycles to do that. And the reason for Mach's expensive border crossing is all due to the fact that there is code bloat resulting in more cache misses and therefore incurring longer latency for border crossing. So in other words, Mach kernel's memory footprint is the culprit for the expensive border crossing. It is not the philosophy or the principle of microkernel-based operating system design, because by proof of construction, L3 has shown that you can have very minimal border crossing overhead by careful construction. Another way of saying it is that portability, which was one of the main concerns in Mach design, and performance are at loggerheads with each other. So if you focus on portability, you may sacrifice performance. And that's what we saw when we look at the difference between Mach's performance and L3's performance on the same processing hardware.